12. How could you write that? So if you prefer to write it like this, you can. Then it would be a 1/6 x squared, a 1/3 x. So first thing we have to do is our derivative. So we get negative 1/4 x squared plus 1/3 x plus 1/3. What do we need to do first? Critical points. Is this ever undefined? No. So critical points are where it equals 0. To find that, if you wanted to get rid of all your fractions, what could you multiply everything by? 12. When you cancel the 4 and 3, let's do a negative 12. So then we would have a positive x squared minus 4x minus 4 equals 0. Hold on, it'll be a 3x squared. So then we can factor. Multiply to a negative 12, add to a negative 4. What would that be? So my critical points. What makes this equal 0? Then what do we have to do? We need to find increasing, decreasing, max, and min, so we need a sign line. So, these points on it. Something smaller, in between, and bigger. And where do we plug these in? The derivative. So those go in here, and we're just checking positive or negative. We don't care what they equal, just the sign. So if we put in -1, we would have a negative times a negative, which is, if we put in a 0, we have a positive times a negative, which is negative. Put in a 3, positive times positive is positive. So this tells me a couple things. Okay, we have a problem actually. What was the very first thing I did on this derivative? I times by a negative 12, right? And that's all well and good in terms of finding it, but my signs are actually the opposite if we put them back in here. Because when I multiply by that negative, because 0 times a negative is still 0, we essentially just lost that sign. Do you guys understand what I'm saying? So my signs are actually backwards. So maybe what would have been better, instead of just multiplying by a negative, know that if you do it, your signs are backwards, but it might have been better if we had factored it out instead of multiplying by it. So if we multiplying by 12 is all well and good, but because of the negative, maybe if we thought of that as just pulling it out instead, and that way we don't get our signs backwards on the sign line. And that was the reason I wanted to do this one together, and then I kind of forgot to mention it until now. So, that negative will flip all of these. Does everyone understand why that happened? Okay, so right here, this was originally a negative x squared. So it means like it's an upside down parabola. If you multiply it by a positive, or by a negative, it flips it. So now it's an upward facing parabola. So all of these signs switched. So instead of multiplying by a negative, just factor it out and keep it for your sign line purposes. So now we know my graph is decreasing from negative infinity to negative 2/3, and from positive 2 to infinity. And it is increasing in the middle, from negative 2/3 to positive 2. What else can we get at this step? If our graph was decreasing and switched to increasing, that gives us a local min. If we are increasing and switch to decreasing, that gives us a local max. We want ordered pairs for those because we have to put them on a graph. How do we get the y values? So if you go back to the very original equation, you guys can help me out here. Negative 10/81. And if we put into we get 2/3. You guys checking me at all? So does everyone know where all of this stuff comes from? What do we need next? Second derivative. Make sure you do that from the original first derivative, okay? We don't want after we multiply by anything. This was the first derivative. So second derivative, I'm going back to that. That would give me a negative 1/2 x squared plus 1/3. And we need to find out when this is 0. Sorry, that wouldn't be x squared, that'd be x, wouldn't it? So is it ever undefined? No. So we just really need 0. So you can multiply by negative 2, and we get 2/3. What do we call this x value? You will have to have an ordered pair in terms to draw it on the graph. So if you want the full ordered pair for graphing purposes, you can go and plug that in.
I'll put that into the original.
Yes, anytime you're getting an actual ordered pair, it goes into the original. And then we need our sine line so we can find our concavity. So something smaller and something bigger. We're putting those into the second derivative. So if I put in a 0, I get a 1/3, so that's positive. If I put in a 1, I would get a negative. So this means our graph is concave up from negative infinity to 2/3, and concave down from 2/3 to infinity. And then we get to draw a graph. So our max, what was that? Our min was at negative 2/3, 10/81, so that's just like barely a tenth. Sorry, that was a negative 10/81. Okay, so those are my maxes and mins. How did I tell you I wanted you to mark inflection points? X's. So that was at positive 2/3, 22/81, which as a decimal is like 0.27. So out of 4. Okay, we know our graph is curved upward until I get to that point. So curved upward, that's like this or this. Oops, not that. We are curving upward, so it could start out decreasing or it could start out increasing. But if we look, our graph was decreasing until I got to that negative 2/3. So it's falling but curved upward. So it would have to look like this. Okay, now we need to be increasing, but we're still curved upward. Once we get to this X, that's like when our graph kind of switches and it's curving downward. And then once we get to that point, it starts falling. So something like that. Any questions for me there? Let's check the rest of this assignment. So if I look at this one, I want to do all the stuff again. You'll notice, how is it different than the other problems I've been giving you? Yeah, this one's in factor form, isn't it? So easier in some respects, harder in others. A little bit easier in terms of like looking at it and finding critical points and that kind of thing. A little bit harder in terms of what do we have to do the derivative? We would either have to multiply it all out or product rule. So let's go ahead and just try keeping it like this and seeing if we can do our derivative with our product rule. So derivative of the first. So derivative of x minus 1 squared. The 2 would come down. Inside stays the same. Subtract 1 from the power, so that would just be to the first. Times derivative of the inside, which is just 1. So this is the derivative of the first. Times the second. Plus the first. Derivative of the second. What's the derivative of x minus 2? So we have 2x minus 1, x plus 2. Plus x minus 1 squared. All right. Now, if I want to find the critical points, I need to know when that is 0. So we have two terms. What could I take out of both terms? So if I take out my x minus 1, then we have a 2, an x plus 2, plus an x minus 1. So if you, inside that, if we multiply it out, we would have a 2x plus x, so 3x. 4 minus 1 is 3. Oh, hold on, I have a mistake. I changed my x minus 2 to an x plus 2 right here. Sorry about that. So that would be negative 4 minus 1, so minus 5. So I have my derivative, it's in factored form now, so now we can figure out what makes it 0. So my critical points would be what? All right, so then if we want increasing, decreasing, max, min, we have to do our sign line. Smaller than 1, in between 1 and 5/3, so maybe a 4/3, and bigger, so maybe a 2. And we're putting those into our derivative. So we could do either version. I'm just going to go ahead and put it in this factored one. So if I put in a 0, I get a negative times a negative, which is positive. If I put in a 4/3, 4/3 minus 1 is positive. And this one you would get 4 minus 5, which is negative, so that's negative. 2 minus 1 is positive, 6 minus 5 is positive, so that section is positive. So this tells me my graph is increasing from negative 30 to 1, and from 5/3 to infinity, and it is decreasing in the middle. We can also get max and mins here. If our graph was going up and switched to going down, that tells us we have a max. To get the y value, you put it into the original. If you put 1 into the original, what do you get? 0. And then at 5/3, we went from decreasing to increasing, so that is a min. Put in 5/3 to the original. We get negative 4/27. All right, now what? Second derivative. We already have simplified the first one, so I'm going to do my derivative from there. So we do product rule. Derivative of the first, so derivative of x minus 1 is 1, times the second, plus the first. Derivative of the second, derivative of 3x minus 5 is 3. Just multiply it out. Inflection point, this is never undefined, so if we set it equal to 0, we get 4/3. So that is the inflection point. When we go to graph it, we will have to have an ordered pair. So if you want, we could go ahead and plug 4/3 back into the original. Negative 2/27, I think. And for our concavity, we have to have a sign line. So we are putting those into the second derivative before we equaled it to 0. So put in a 0, you get a negative, put in a 2, you get a positive. So our graph is concave down to start with. Mm-hmm. Inflection point we mark with an X. And so 4/3, that's like 1 1/3, negative 2/27, that's just barely negative. We know we are curving downward until we get there, and upward after. We have a max at 1, 0. And a min at 5/3, negative 4/27. So now we just have to make our graph match. It said we start out increasing until we get to 1. So our graph is rising and it is curved downward. So when you're rising, you have two options. You can be rising curving downward or rising curving upward. We're the first one because we're concave down. And this is our high point. So start out like this. Then we still have to be curved down, but we start decreasing. Once we hit our inflection point, our concavity changes, we're curving upward. And when we get to this point, after that 5/3, we start increasing again. And we remain curved upward. Any questions on that one? Let's go ahead and do the last problem. So this is 2 over x squared minus 1 over x plus 4. This one has asymptotes. How do you find a vertical asymptote? What makes the bottom 0? What makes the bottom 0 on this? 0. So x equals 0 is a vertical asymptote. Horizontal asymptote, we've done this. What did we have to do? These are the limits.
That means this approaches 0.
As we approach positive and negative infinity. Mm-hmm. Okay, 2 over infinity is going to, if I have 2 pizzas and I invite more and more people to eat with us, it's going to 0. 1 over infinity is going to 0. Remember, a number over positive or negative infinity always goes to 0. So this is just giving me 4. We should check as we go to negative infinity. We talked about most of the time they're the same, but I did show you examples where they were not. But if x is negative infinity, it doesn't change anything. 2 divided by a bigger and bigger number is 0. 1 over a bigger and bigger number is 0. So this is also going to 4. So horizontal asymptote y equals 4. All right. Now we can do all of our stuff. We need our derivative. You can think of it like this. It might be easier for derivative purposes to think that's like 2x to the negative 2 minus x to the negative 1. So we need our first derivative. So that's negative 4x to the negative 3 plus x to the negative 2. Okay, if you don't like how that's written, that's negative 4 over x cubed plus 1 over x squared. What do we need to find? Critical points, when this is 0 or undefined. Can you tell me when it's undefined? When the bottom is 0. So x equals 0 is a critical point. We have that over. The only other critical point we get is 4. So if we do our sign, we are doing these for the derivative. So if you put in a negative 1, we get 4 plus 1, so that's positive. Put in 1, we get negative 4 plus 1, which is negative. And 5 also give us a positive. Alright, if you go from increasing to decreasing, that is a to get the y, you put it back in the original, but can you put 0 in the original? No. So that means this is not really a max because we can't have it. It's a vertical asymptote, so there is no max here. Our local min, we put in 4 to the original. And what do we get? .875 if you want a decimal. Next step is second derivative for concavity. So go back here. If I do that derivative, we would get 12x to the negative 4 minus 2x to the negative 3. So that means 12 over x to the 4 minus 2 over x cubed. We need anywhere that is 0 or undefined. Different ways of solving it. Last time I showed you, you could add it over and cross multiply. You could just say, I'm going to take everything times x to the 4th and get rid of your denominator. And that's also an option. So just trying to show you different options for writing it. So we can do a 12 minus 2x. So then we see x is 6. So my inflection points. 0 because that makes it undefined, and 6 because that makes it 0. We know we need actual order pairs when we go to graph them. Can we plot 0? No, that's an asymptote. But we could put in 6, and if I put 6 into the original, it's not going to be pretty. It's about 3.89. I'll go ahead and give a decimal so we can approximate it on our graph. Concavity, need our sign line. We're plugging these into our second derivative. So come in right here. If I put in -1, I get 12 minus -2, so that's positive. Put in a 1, we get 12 minus 2, so that is still positive. Put in a 7, and then we get a negative. Now, I actually cannot just say it's concave up from -infinity to 6. Does anyone know why? Vertical asymptote. We have a break in our graph. So we have to say from -infinity to 0, union 0, 6. Because we know at 0 our graph doesn't exist. And concave down after that. Alright. So, this one, we have a vertical asymptote at 0. Horizontal asymptote at 4. Hopefully your line's a little bit straighter than mine. Okay, we have an inflection point at 6, 3.89. We know our, let's see, we did not have a max, but our min was at 3.875. So very, very close to this. Sorry, that's min. Okay, so we start out, our graph is curving upward and increasing. And we know as you get, when you're dealing with asymptotes, your graph is approaching it. So going upward, curving upward and increasing would look like this. Then we have to stay curved upward, but our graph is going to decrease until I get to 4. So curving upward, but falling, so it means I'm going to cross my horizontal asymptote. Then we're staying curving upward until we get to this X. Our graph is going to increase for the rest of the time. So curving upward and increasing, and then it just switches to curving downward. So it's still rising, but it's flattening out there. And I know it gets tricky to plot these when we have points so close together, but we're just doing the best we can with it. All right, so questions for me. Going to give you guys a few to practice. We are going to keep practicing this for several days, so probably the rest of the week we'll be on the same thing. I want you to do 3 book problems.